Okay, so the title of this talk is called VisLitE Visualization Literacy and Evaluation. And it's a collaboration between myself, Elif, Firat, and Alark, Joshi. Elif is a former PhD student at the University of Nottingham that graduated, right, and went back to Turkey. Also, this article was published in a journal called IEEE Computer Graphics and Applications last year. So it's a presentation of a journal article. A little bit of background behind the history of this paper. This is not standard, by the way. This is not a standard slide. I just thought it would be helpful to give the background behind the inspiration of this paper. So the way this story started, we originally submitted a state-of-the-art report, now you all know what those are, on visualization literacy to the journal called IEEE Computer Graphics and Applications. That paper was rejected from the journal. But somebody noticed that it would make a modified version of it, a smaller version of it, would make a good candidate for the educational department. So somebody then suggested to Beatrice that we submit a modified, shortened, pedagogical version of it to the educational department in IEEE CG&A. So that's what this is. It's a shortened, educational style version of the STAR report. And as a result, we make a lot of references to the state-of-the-art report in the VisLitE paper. Since IEEE CG&A limits the number of references you can have, it actually limits the number of references to something like 10 to 12. We get around that by citing the survey when we need extra citations. Does that make any sense, hopefully? Okay, so what's the motivation for this topic, visualization literacy, right? I saw this quote the other day. I thought it was quite fitting. It's difficult to learn from something you can't see. But that's a quote from a very different kind of book, Psychology of Money. So the topic of visualization literacy is rapidly growing in importance, right? That's because there's a rapid growth in the topic of data literacy. So in order to make sense of data, we need visualization. Data and its visual representation are used more and more to support understanding and decision making. Developing visualization literacy is essential to support data cognition and evolve toward a more informed society. This is a figure, by the way, that shows the number of papers published over time on the topic of visualization literacy. Right? And it's growing over time. And it's color-coded by the kind of paper and the kind of evaluation that the paper involves. And we're going to talk more about that in the forthcoming slides. So the way this talk is organized, we start out with definitions of visualization literacy, then we talk about evaluation and evaluation styles and why it's important. And then we look at a few examples, and then we finish up. So the contributions of this paper are, it's the first introduction of its kind on the topic of visualization literacy with a special emphasis on evaluation. The reason evaluation is a special emphasis is because it's difficult. It's really difficult to perform a successful evaluation of whatever visualization literacy test you're developing or whichever visualization literacy software you're developing. It's a challenge, so then we put a special focus on that. We offer a literature classification of research papers in this area and beneficial meta-analysis to facilitate comparison of the papers. And then we also indicate areas that are mature and areas with unsolved problems. This is a figure, by the way, that shows the different visual designs that have been evaluated in the literature, right? And through the lens of visualization literacy, right? We can see bar charts have been evaluated very often, or the most often, scatter plots, line charts, pie charts, histograms, choropleths, stacked bar charts, tree maps, parallel coordinates, and so on. So it gets less and less frequent as you move down the ladder, so to speak. So visualization literacy is defined, it has different definitions, right, by different authors. One definition is a concept generally understood as the ability to confidently create and interpret visual representations of data. Berner et al. Define visualization literacy as the ability to make meaning from and interpret patterns, trends, and correlations in visual representations of data. Lee et al. Define it as the ability and skill to read and interpret visually represented data and extract information from data visualizations. So it's very much analogous to language literacy, reading and writing, financial literacy, computer literacy, data literacy, and there are two fundamental aspects: reading and interpreting, and then construction and creation. So you can think of that as reading and writing, right? Reading and interpreting, and writing and creating. All the literature, we divide the literature based on its evaluation style. Like, how are these tools and tests that are developed to enhance visualization literacy, how are they evaluated? And the evaluation categories generally fall into four types. There are so-called in the wild studies, so those are so-called real-world studies. That's when the experiment is opened up to the general public in real life and in person. You don't have a controlled lab environment. You don't know who's coming to test your software or take your visualization literacy tests. And you don't have as much control over the environment. We also have controlled user studies. These take place in a laboratory with very well-known settings and a lot of control over the environment. Right? It's typical that a user or a participant sits in front of a computer or in front of a test, and they're given a set of tasks, and those tasks are carefully monitored for things like response time and accuracy. Then we have classroom settings in person. So that's when a class like this is used to evaluate some visualization literacy software or tests. And it often happens that the class is divided into two groups: a control group that undergoes the standard procedure or the standard educational procedure, and then an experimental group that undergoes a new procedure, a novel procedure that's supposed to enhance their visualization literacy. And then we have crowdsourced evaluations, right? These evaluations take place online, and they're available to the entire internet world. Anybody with internet access can participate in these experiments and take the tests or try out the software and so on. And we can see that the classroom-based experiments are currently the most popular, followed by the crowdsourcing experiments. And this is just a little comparison of the different evaluation characteristics. Right, in the wild, we tried to ascribe these attributes to the different kinds of evaluations, like the physical distance involved between participants, the proximity of the observations, the control over the environment, and the number of participants. These are all kind of typical qualities of the evaluation styles. And we can see, for example, the distance in the wild evaluation studies is medium, so-called medium, somewhere in the middle. The proximity of the observations is somewhere in the middle, and the control over the environment is somewhere in the middle, and it usually involves more participants than, say, a lab-based study. In a controlled user study, we have tight control over the environment and the hardware used and the software. We observe, we make close observations. We observe every single task that each participant is making, right? And we're watching them from a close distance, and we have a high control over the environment and so on. So the control over the environment is really an important characteristic, and the number of participants is also very important. So generally, the more control you have over the environment, it can happen that it's harder to get more participants, right? And the less control you have, the easier it is to get more participants. Okay, these are just some examples. So here's an example of a visualization literacy research paper where the authors went into a science museum and they recruited people from the science museum, people visiting the museum, to conduct an interview. And they showed them these different visual designs, these different images, and they started asking them a structured series of questions about those images and those visual designs, like how familiar are you with this, and what would you call it if you had to give it a name, and when do you think it would be useful, and so on. And then they used the interview data to, one, assess the visualization literacy of the general populace, and two, to rank the images by difficulty. That's an example of an in-the-wild evaluation. Here's an example of a controlled user study. In this case, each participant is given two things: a set of data and then a set of tiles. And they ask the participants to create some visual representation of that data with the given set of tiles. And that's it, to find out what the users do. And they want to understand the visual mapping process, like how does the user reason about the data, and how do they reason about the visual representation of that data, and what might be the easy reasoning processes and what might be the difficult processes. Here's an example of a classroom-based evaluation. So this is a piece of software to enhance tree map literacy. So on the left side, we have a hierarchical view, a standard hierarchical view of a hierarchical data set. And then on the right side, we have the tree map representation. And the two views are linked to each other. So if the user interacts with the left tree, then the interaction is reflected in the right tree map, right? And this is supposed to support the understanding of tree map literacy. And here's an example of a crowdsourced-based evaluation. So this is a generalized visualization literacy test that could be given to anybody. And the way the authors developed is they found the 12 most common visual representations by searching through K-12 literature, visualization tools, news articles, and they came up with the 12 most popular visual designs. And then they designed a visualization literacy test to test participants on their knowledge of these 12 most popular designs. Okay, so if we look at the literature and we look at what the most promising future research directions are, we see further evaluation, new visual design types, of improving visualization literacy software, improving visualization literacy tests, testing on larger or new target groups, studying cognitive impact, and testing on larger data sets. Those are the most common future research directions. And if we look at the contributions made by visualization literacy, we see that some of the visualization research contributes visualization literacy tests, some of it contributes visualization literacy software, and then we have a bunch of other styles of contributions. Okay, I'm at 15 minutes exactly. Any questions about the visualization literacy introduction?